Hello and welcome. In this section of the course, we will learn how to perform a topological sort on a graph. We will start by looking at some use cases and examples. Later, we will pick up two algorithms and implement them. These are known as Kahn's algorithm and the DFS topological sorting. But let's first start by looking at some practical applications. Specifically in this video, we will explain what a topological sort is and see some use cases. So what is a topological sort? Simply put, it's an ordering of the nodes in a graph. Basically, if an edge from node U to node V exists, as in this diagram, then node U should come before node V. It's important to remember that topological sorts can only work if the graph is a direct acyclical graph. This is because if our graph contains a loop, there is no clear order which nodes should come first. Here is a very simple graph showing the problem. If we have two nodes, both pointing at each other, which one should come first? Let's now have a look at an example graph for which we can compute the topological sort. Imagine you were to write a computer game. To keep your program clean and tidy, you divide your code in various modules and libraries. At the base, you have the main game logic. This game depends on various other modules such as your graphic module, your physics library, and an AI engine. The game also allows you to play with other remote players, so you also have a networking module. You also have a logging API that is used both by the top-level game and the networking module. A number of your modules also depend on a math library. And finally, you have a commons component which is used by both the math and your physics library. This is your build dependency graph. You need to follow a specific order to be able to build the modules. For example, you cannot build the physics module before you build the math and the commons. If we want to build the entire system, we can, for example, start with the commons and then the math. And now we can build the physics, since both the math and the commons module are ready. Next, we can do graphics, the AI engine, and then we can pick the logging module, for example. And after that, we do the networking. At the end, we can finish off with the main game module. This is one possible ordering of the topological sort. Typically, for any particular graph, there is more than one solution. For example, we could have started from the logging module, and it would have still produced a valid topological sort. There are many other important applications for topological sorting. The example we saw in the previous slides was for building and linking code. Job scheduling is another common application for topological sorting. This is when you schedule a job if all the other jobs that depend on it have been completed. Topological sorting is also commonly used for data serialization. Imagine, for example, you have an object graph that you want to serialize. The graph needs to be serialized in the correct order for data serialization to work. Topological sorting is also used in dependency injection tools such as Spring or Google Juice. Using topological sorting, the correct initialization sequence of beans is computed from the dependency graph specified in the application context. This sequence is then used to create each object one after the other. Ordering nodes in a graph has many important applications in many areas. In this video, we have seen an example of a topological sort and outlined other applications where it can be used.